Hello dear students, I hope you are fine and doing well in your studies. Students, today we are going to start from where we have finished in the previous session. Student, in this session, we will do some basic questions, examples, theorems, which are important regarding to this chapter. So, let us begin with the chapter itself. Students, in the category of simultaneous equations, we are going to study two equations in one unknown here. Find the most general values of theta which satisfy the equation sin theta is equal to minus half, tan theta is equal to 1 by root 3. What is the main fundamental method to solve this type of questions? First of all, we have to find the quadrant in which the sin theta is negative and the quadrant in which tan theta is positive. And as we know, any trigonometric ratios are negative in two quadrant and positive in two quadrant. So we can say that sin theta is negative in quadrant number 3rd and 4th, and tan theta is positive in quadrant number 1st and 3rd. The third quadrant is the common quadrant. Now we have to find the value of theta for which sin theta is equal to minus half and tan theta is equal to 1 by root 3. As we know, sin theta is equal to minus half, theta is equal to 7 pi by 6, which lies in the third quadrant, or 11 pi by 6, which lies in the fourth quadrant. And tan theta is equal to 1 by root 3, theta is equal to pi by 6 for the first quadrant, and theta is equal to 7 pi by 6 for the third quadrant. This is the common angle. We find the value of common angle, then the required general solution is theta is equal to 2n pi plus 7 pi by 6. This is the solution of both these equations. Means for different values of n, we get different theta, and that theta will satisfy these both equations simultaneously. This is the two equations in one variable. Student, here we are going to study problem based on boundary conditions. As we know the boundary condition, sin theta lies between minus 1 to 1, cos theta lies between minus 1 to 1, sec theta is greater than equal to 1, and cosec theta mod is greater than equal to 1, and tan theta mod is greater than equal to 0, and same cot theta mod is greater than equal to 0. If the problem involves only one equation consisting of more than one variable, or equation involves variable of different natures, then the boundary condition of trigonometric function is generally used. Find the general solution of the equations. This. How we can solve it? As we know, cos 2 theta is equal to 1 minus 2 sin square theta, or it is equal to 2 cos square theta minus 1. Then we can write it is sin square x whole square plus cos square x whole square is equal to sin x into cos x. As we know, sin 2x, or we can say sin 2 theta is equal to 2 sin theta cos theta. Now apply sin square x from here. Sin square x can be written as 1 minus cos 2x upon 2 whole square. Similarly, cos square x can be written as 1 plus cos 2x upon 2 whole square, and sin x cos x can be written as sin 2x upon 2. Now simplify it. It is 1 minus cos 2x whole square plus 1 plus cos 2x whole square is equal to 2 sin 2x. Now again simplify it. It is the 1 plus cos square 2x minus 2 cos 2x plus 1 plus cos square 2x minus 2 cos 2x is equal to 2 sin 2x. Now it is cancel out because it is the plus sign, it is the minus sign, it is cancel out. Now it will become 2 plus 2 cos square 2x is equal to 2 sine 2x. Now simplify it. 1 plus cos square 2x is equal to sine 2x. Now again simplify it. We can write down 1 plus 1 minus sine square 2x is equal to sine 2x. Now simplify it. Sine square 2x plus sine 2x is equal to 2. Now here we are going to use the boundary condition, means this relation is possible only when sine 2x is equal to 1. We can find the solution. Sine 2x is equal to 1 means 2x is equal to 2n pi plus pi by 2, and simplify it. We can find x is equal to n pi plus pi by 4. This is the answer of our equation, or it is the general solution of the equation sin to power 4x plus cos to power 4x is equal to sin x into cos x. Student, let's see one more example. Solve the equation e to power cos x is equal to e to power minus cos x plus 4. We can write e to power cos x is equal to 1 upon e to power cos x plus 4. Let e to power cos x is equal to t. The equation will become t is equal to 1 upon t plus 4. Now simplify it. T square is equal to 1 plus 4t. Now simplify it. T square minus 4t minus 1 is equal to 0. Find the value of t. T is equal to minus b plus minus b square minus 4ac upon 2a, and it is equal to 2 plus minus root 5. The value of t is e to power cos x. E to power cos x is equal to 2 plus minus root 5. 2 minus root 5 is not possible because e to power cos x is greater than 0. You can say that e to power cos x is equal to 2 plus root 5. Taking log on both sides, we can write cos x is equal to log 2 plus root 5, that is greater than 1. We can see cos x greater than 1. It is impossible. So there is no solution of this equation. Means the equation has no solution. Student, let's see one more example. 2 cos square x by 2 into sin square x is equal to x square plus x to power minus 2, where x belongs to 0 to pi by 2. Students, in this problem, term on two sides of the equation are different in nature. LHS is in trigonometric forms, whereas RHS is in algebraic form. Hence, we will use boundary conditions. LHS can be write down 2 cos square x by 2 into sin square x. We can use the formula here. It will become 1 plus cos x into sin square x. It is always less than 2. Since 1 plus cos x is less than 2 and sin square x is less than equal to 1. And RHS here is x square plus 1 upon x square, that is always greater than equal to 2. Hence, LHS is never equal to RHS. Therefore, the given equation has no solution. Student, let's see trigonometric inequations. To solve trigonometric inequation of a type fx less than or equal to a or fx greater than or equal to a, where fx is some trigonometric ratios, we take following steps. Step 1. Draw the graph of fx in an interval length equal to the fundamental period of fx. Step number 2. Draw the line y is equal to a. Step number 3. Take the portion of the graph for which inequation is satisfied. Step number 4. To generalize, add Pn where n belongs to integer and take union over set of integers where p is fundamental period of fx. Student, let's see one example. Example is here. Find the solution of tan x greater than minus 1 by root 3 and less than equal to 1. According to the rule, first of all, we have to draw the graph of tan x and plot the line of y is equal to 1 and y is equal to minus 1 by root 3. Student, here is the graph. This is the graph of tan x and it is the line y is equal to 1 and it is the line y is equal to minus 1 by root 3. Now student, the value of tan x is greater than minus 1 by root 3 means the graph will be above the line y is equal to minus 1 by root 3 and tan x less than equals to 1, the graph of tan should be below the y is equal to 1 line. We can see the reason satisfy this condition is from minus pi by 6 to pi by 4 means we can say the solution of this inequation or inequality is x greater than minus pi by 6 or less than equal to pi by 4. The general solution of inequality will be n pi minus pi by 6 less than x and less than equal to n pi plus pi by 4. This is the general solution of this inequality. Student, let's see one more example. Find the solution set of the inequation sin x greater than 1 by 2. To solve this equation, we have to draw the graph of y is equal to sin x and y is equal to half and find the intersection points of the graph and then region where sin x is greater than 1 by 2. Here is the graph of sin x and graph of y is equal to half. Within a period of length 2 pi, we can observe that from pi by 6 to 5 pi by 6, the value of sin x is greater than half. Then we can say the answer of this inequality is x greater than pi by 6 to 5 pi by 6. And for general solution, we are going to add 2n pi because 2 pi is the period. Then we can say the answer of this equation, this inequality is 2n pi plus pi by 6 to 2n pi plus 5 pi by 6. This is the answer of inequality sin x greater than 1 by 2. Students, now we are going to study a topic height and distance. One of the important application of trigonometry is in finding the height and distance of the point which are not directly measurable. This is done with the help of trigonometric ratios. What is the angle of elevation? Let O and P be 2 points where P is at a higher level than O and O be at position of the observer and P be the position of the object. Draw a horizontal line OM. This is the horizontal line OM through the point O. OP is called the line of observation or line of sight. Then angle POM is equal to theta is called angle of elevation of P as observed from O. This is the angle of elevation, this is the horizontal line and this is line of elevation. Now what is the angle of depression? In this figure, if P is at lower level than O, then angle MOP is equal to theta is called the angle of depression. Here P is the lower level and this angle is called the angle of depression. It is the line of observation and it is horizontal line. Let's see one example here. The angle of elevation of top of a tower standing on a horizontal plane at a point A is 15 degree. After walking 40 meters from A towards tower, this angle becomes 30. The height of the tower is option A 40 meter, option 2 20 meter, option 3 20 root 3 meter and option 4 40 upon root 3 into root 3 meter. Let's see the figure of this question. A is a point, B is a point and the distance between AB is 40 meter. Angle of elevation is given 15 degree and this is the 30 degree. That's why this is interior angle for the angle PBQ and PAB. we can find the angle PBA, that is 15 degree. Now we can see the angle are equal, that's why sides are also equal. This is a triangle. In this side equal to this side, means this is 40, then this is also 40. That it is H. Then we are going to find sine 30. What is the value of sine 30? The value of sine 30 is H upon PB. As we know, what is the value of PB? PB is 40. Then what is this? It is H upon 40. Then what is the height of the tower? Height of the tower is 40 sine 30. What is the value of sine 30? Sine 30 is half. It is the 40 into half is equal to 20 meter. This is the height of the tower. This is very easy type of question. Okay students, let's see one more question. The angle of elevation of top of a tower at 2 points which are at a distances A and B from the foot in the same horizontal line and one of the same sides of the tower are complementary. The height of tower is, first of all, we have to draw this figure, and length AQ is A and length BQ is B. Angle PAQ is alpha and angle PBQ is beta, and these are the complementary angle. What is the meaning of complementary angle? Alpha plus beta is equal to 90. What is the tan alpha? In the triangle PAQ, tan alpha is equal to H upon A. This is the equation number first. In the triangle PBQ, tan beta is equal to H upon B. It is the equation number 2. Now multiplying these two, tan alpha into tan beta is equal to H square upon AB. As we know, alpha and beta are complementary angle, then we can write tan alpha into tan beta is 90 minus alpha is equal to H square upon AB. What is the 90 minus alpha? It is cot alpha. And what is the product of tan alpha and cot alpha? It is 1. Means 1 is equal to H square upon AB implies H square is equal to AB implies H is equal to square root of AB. This is the height of the tower. Student, let's see one more example. From the top of H meter high cliff, the angle of depression of the top and bottom of a tower are observed to be 30 degree and 60 degree respectively. The height of the tower is option 1 2h by 3, option 2 h by 3, option 3 2h by root 3, and option 4 h root 3. First of all, we are going to draw the graph of this question. This is here. Let PQ is the given tower and height of the tower is x meter, or you can say x unit. This is the height, given height, or you can say it is the meter. And top of h meter high cliff, this is the h meter. Angle of depression are given. Angle of depression for the top and angle of depression for the bottom are respectively 30 and 60. Now this is the right angle triangle AQB and a triangle APC. In the triangle AQB, what is the value of tan 60? The value of tan 60 is H upon QB. As we know, QB is equal to PC. In the triangle APC, what is the value of tan 30? The value of tan 30 is H minus X whole upon PC. As we know, PC is equal to PQ, means it is H minus X upon QB. This is the QB. And what is the value of QB from here? As we know, tan 60 is the root 3 and the value of QB is H upon root 3, means it is equal to H minus X upon the value of QB is H upon root 3, means it is multiplied by root 3 is equal to tan 30. What is the value of tan 30? It is the 1 by root 3. Now simplify it. H is equal to 3 H minus X. Simplify it again. h is equal to 3h minus 3x, 2h is equal to 3x. That's why x is equal to 2h by 3. Option 1 is the correct answer. Height of tower is 2h by 3, where h is the height of the given cliff. Now let's see example number 4. From vertically situated aeroplane to the straight horizontal road, the angle of depression of two consecutive kilometer stones are alpha and beta. If an aeroplane is in vertical plane in between two stones, then the height of the aeroplane from the road will be. This is the stones and the distance between the stones is 1 kilometer. Means distance AB is 1 kilometer. And this is the position of aeroplane and angle of elevation is given. This is the angle of depression and it is the, you can see, angle of elevation. It is the alpha, that's why it is also alpha. It is beta, that's why it is beta. Now we are going to find the height of the aeroplane. Let height of aeroplane PQ is h. Now in the triangle PAQ, what is the value of tan alpha? The value of tan alpha is h upon AQ. In the triangle PBQ, what is the value of tan beta? The tan beta is h upon QB. From here we are going to find the value of AQ. It is h upon tan alpha, and from here QB is equal to h upon tan beta. As we know, AQ plus QB is equal to 1, means h upon tan alpha plus h upon tan beta is equal to 1. Now simplify it. H is common. LCM is tan alpha into tan beta, and it is tan alpha plus tan beta is equal to 1. Simplify it. H is equal to tan alpha into tan beta whole upon tan alpha plus tan beta. This is height of the aeroplane, and option 1 is the correct answer. Students, let's see one more example. The angle of elevation of a cloud from a point situated at a meter height from the lake is alpha, and the angle of depression of its reflection is beta. Height of cloud is, and option 1, 2, 3, 4 are given here. Okay, now first of all we are going to draw the diagram of this picture. Means where is the cloud, where is the pond. Let this is a diagram. Let BT be the horizontal position of the lake and A be the given point at height h above it. This is the point A. If the position of cloud and its reflection be P and Q respectively, cloud and its reflection, then from the diagram you can say that angle PAC is equal to alpha and angle QAC is equal to beta. Let h be the height of the cloud. H be the height of the cloud. Then from triangles PCA and QCA, we can say h minus A upon AC is equal to tan alpha. This is the equation number 1. And h plus A upon AC is equal to tan beta. This is the equation number 2. Now we are going to solve these two equations. Second is divided by first. It will give h plus A upon h minus A is equal to tan beta upon tan alpha. Now we are going to simplify it. It will convert 2h upon 2A is equal to tan beta plus tan alpha upon tan beta minus tan alpha. Now convert the tan into sin and cos. 2h upon 2a is equal to, it is sin beta into cos alpha plus sin alpha into cos beta whole upon sin beta into cos alpha minus sin alpha into cos beta. H is equal to a times, what is the formula? It is sin alpha plus beta whole upon sin beta minus alpha. What is the answer? Answer is option A. This is the correct answer. Students, let's see one more example. A tower is 100 root 3 meter high. Find the angle of elevation of its top from a point 100 meters away from its foot. And answer is option 1, theta is equal to 60 degree. Option 2, theta is equal to 45 degree. Option 3, theta is equal to 30 degree. And option 4, theta is equal to 20.5 degree. Students, let a tower of height 100 root 3 meter is here, suppose, and it is the foot and it is the top. From the foot of the tower, there is a ground, and at a distance of 100 meter, there is the angle of elevation, and that angle we have to find. Let the angle of elevation is theta. Height of tower is 100 root 3. It is very easy questions. This triangle is a right angle triangle. Let it is the ABC. You can see angle BAC is the right angle and theta is the angle ACB. Then find tan theta. What is the value of tan theta? It is 100 root 3 upon 100 and it is equal to root 3. As we know, the value of theta pi by 3, at which tan theta is root 3, means theta is equals to 60 degree or pi by 3. Your angle of elevation is 60 degree and option 1 is the correct answer. Students, let's see one more questions. The top of a hill observed from the top and bottom of a building of height h is at angle of elevation p and q respectively. The height of hill is option 1, h cot q upon cot q minus cot p. Option 2, h cot p upon cot p minus cot q. Option 3, h tan p upon tan p minus tan q. And option 4 is none of these. First of all, we have to draw the pictorial diagram of this question. Let's see, diagram is here. Let the building of height h is here and top of hill, this is the hill and p is the top of the hill. Let BP is the hill, means BP is hill and given building is AD. AD is the building and the height of AD is h. You can say AD is equal to BC is equal to h, and let distance CP is equal to x. Here PCD and PBA are the right angle triangle and the angle of elevation are P and Q respectively. In the triangle PDC, what is the value of tan P? The value of tan P is x upon CD. You can say it is, let it is y, means it is x upon y. And in the triangle PAB, the value of tan Q is x plus h upon y. Now we have to find the height of the hill, means we have to find x plus h. So first of all, we have to find the value of x from the equation number 1 and 2. Put the value of y from the equation 1 to the equation number 2. What is the value of y? The value of y is x upon tan p. Then tan q is equal to x plus h upon x upon tan p. It is the tan p. Now simplify it. It is tan q upon tan p is equal to x plus h upon x. Now again simplify, it is 1 plus x upon h. Now further transfer the 1 and we can find that x upon h is equal to 10q upon 10p minus 1. Now simplify it, it is 10q minus 10p whole upon 10p. This is x upon h upon x. Now x is equal to h 10p upon 10q minus 10p. What is the value of x plus h? The value of x plus h is equal to x 10p whole upon 10q minus 10p plus h. Now again simplify it, h is common and it is 10p plus 10q minus 10p whole upon 10q minus 10p. After solving, 10p and 10p is cancel out and our answer is h 10q upon 10q minus 10p. What is the solution of this h 10q? There is no. Then we have to convert this into the cot. Then h, what is the 10q? 1 upon cot q. It is 1 upon cot q and 10q is 1 upon cot q and it is 1 upon cot p. Now simplify, then we can find the option 2 is the correct answer because cot p is remaining and it is the cot p minus cot q. The answer of this question is option number 2. Okay students?